All right, so today we're going to do May-June 2024, paper 41. Paper 4, variant 1. A student finds the concentration of a dilute acid, HA, by titration. HA just means you have H plus A minus, right? This is like HCl and Cl minus and so on. Some general acid. We don't know what A is. The student adds 25 cm cube of aqueous sodium hydroxide to a flask. And then he adds a few drops of methyl orange indicator to the aqueous sodium hydroxide. And then you slowly add HA from the burette, right? So HA is being added from the burette. So you have HA in the burette and you have sodium hydroxide in the flask. Figure 1.1 shows the apparatus the student uses to measure 25 cm cube of aqueous sodium hydroxide. Name the apparatus shown. Measuring cylinder. Yeah. Name a more suitable piece of apparatus, a pipette. So बस आप लोगों को ये याद रखना है सही है कि 25 cm cube के लिए a pipette is much more accurate. सही है, for 25 cm cube pipette, for 25 cm cube pipette is much more accurate. 1, 2, 5, 10, 25. 1, 2, 5, 10, 25. अगर आपको वो volumes measure करनी है, if you want to measure these specific volumes, then a pipette is better. Okay. Figure 1.2 shows the apparatus used to determine the volume of HA at the end of the experiment. That would be the burette, right? Because your titration may you're adding HA from the burette. Aapka sodium hydroxide is in the flask, right? Sodium hydroxide is in the flask and the acid is being added from the burette. The initial reading on the apparatus is 1 cm. Use figure 1.2 to determine the volume of HA used in the titration. So over here, we have the final volume. Again, burette ki reading is top to bottom read karte 23.5, 23.6, right? 23.6 and the initial volume is 1.0. So 23.6 minus 1.0. So the volume added, yes, volume added is 22.6 cm. The student washes the apparatus before it is used. State the substance used to wash the apparatus. Whenever you're using a burette in a titration, you should use the same thing that you're titrating with, right? Or titrating against. तो अगर आप अपनी titration में acid डाल रहे हो burette में तो आपको burette को उसी acid से धोना है. Okay, if you want to put the acid in the burette, you should wash the burette with the acid itself. Okay, so first we wash the burette with distilled water and then we wash the burette with the acid. Describe the color change of the methyl orange at the end point. So initially you added methyl orange into the conical flask. Conical flask mein you add sodium hydroxide. Okay, methyl orange is yellow in alkali and it turns red or pink in acid. Okay, it's yellow in alkali and pink or red in acid. So yellow to pink. Okay. You can say red, but right at the end point you have very little acid extra. You have very little excess acid, so it's gonna be pink. हाँ, आप लोगों के लिए 25 मैक्स है पिपेट का, सही है, इससे ज़्यादा नहीं होगा पिपेट का. A student investigates the reaction of 4 metals, A, B, C, and D, with aqueous copper 2 sulfate. The 4 metals are all gray solids. The student puts 25 cm cube of aqueous copper 2 sulfate into a beaker and measures its temperature. Records this temperature in table 2.1. So 25 cm cube of aqueous copper 2 sulfate and you determine the temperature. You add a sample of A, which is one of the metals, to the aqueous copper 2 sulfate. Stir the reaction mixture until there is no further increase in the temperature. Now, if the temperature is increasing, it means we have an exothermic reaction. Measures the highest temperature of the mixture and records this temperature in table 2.1. Observes any changes in the appearance of the mixture in the beaker. The student repeats the experiment 3 more times using B, C, and D instead of A. So basically, he does it with each of these metals. So he adds a metal of each. He adds a sample of each of the metals to copper 2 sulfate and determines how much the temperature increased. Okay, by measuring the initial temperature and the highest temperature and finding the difference. The results for A, B, and C are shown. State the value in table 2.1 which the student records to an incorrect degree of precision. This is the value recorded to an incorrect degree of precision, right? It should be to 1 decimal place. 20. Just have to state the value. So the value incorrectly written is 20. The temperatures for D are shown in figure 2.1. Record these temperatures in table 2.1. Calculate and record the temperature increases for B and D. So first, D ka initial temperature is 21.0 and the final temperature is, this temperature is between 53 and 54, so it will be 53.5. Okay, if you have a scale that shows every 1 degree Celsius, okay, you can measure to the nearest 0.5. It's always half the minimum graduation. The minimum graduation here is 0.1. That's the minimum graduation. Oh, sorry, 1. Right, the minimum graduation is 1, which means you can record to the nearest 0.5. Right, so over here it would be 53.5. And then the temperature increase for B would be 46 minus 24.5, which is 21.5, and 53.5 minus 21.0, which is 32.5. The equation for the reaction between B and aqueous copper 2 sulfate is shown. At the end of the experiment, the student observes a colorless solution, a gray solid, and a brown solid. Explain how these observations show that B is an excess in this reaction. The question clearly says that A, B, C, and D are gray solids. Now that means that some of the B is left over, right? Some of the B is left over and all the copper 2 sulfate has reacted, right? Because some of the gray solid is left over, it means there must be an excess. Now the brown solid that you're seeing is copper metal. Copper metal is like a pinkish brown color. Okay, in some places you're gonna see pink, also brown, right? It's like a pinkish brown, like a bronze color. So the observation that shows B as an excess is the fact that the gray solid is left over, right? So gray solid B remains or does not completely react, right? Does not completely react. Using the equation in part 3, write down the formula for the colorless solution, the gray solid, and the brown solid. The colorless solution is BSO4 aqueous, right? Because आपका जो solution बन रहा है aqueous colorless है, right? The blue solution disappears because copper 2 ions are converted to copper metal, right? तो आपका colorless solution is BSO4 aqueous. Okay, your gray solid is B, which is the solid, gray metal, and your brown solid is copper. Use your results to arrange A, B, C, and D in order of decreasing reactivity. Decreasing order of reactivity. So we're going to start with the most reactive at the top. Now the most reactive one will give you the biggest temperature increase, which is A, followed by C, followed by D, followed by B. So A, C, D, B. A, C, D, B. And the explanation here is that the greater the temperature change, the more reactive the metal. Okay, अगर हम दोबारा टेबल को देखें, इसका सबसे ज़्यादा टेम्परेचर इंक्रीज है तो सबसे ज़्यादा रिएक्टिव है, followed by C 39, followed by D, followed by C, right? So the greater the temperature change, the more reactive the metal. A student repeats the experiment using a fifth metal. This metal is the second most reactive of the five metals. Suggest a temperature increase for this experiment. The second most reactive means it's more reactive than C but less reactive than A. So it will be somewhere between A and C. Somewhere between A and C. So around 44 degrees, right? That's it. Any number in between. Any number in between. So the suggest question just means that you just have to give a number that could be valid, right?
सही। तो इसमें यूनिट्स का नहीं होता?
नहीं होता है, लिख रहा हूँ 44.0 degrees Celsius. The temperature increase, the temperature increases measured are less than the true values for these experiments. Suggest a reason for this and describe an improvement to the method which makes the results closer to the true values. So if the temperature increases are lesser than they should be, यानी कि सवाल ये कह रहा है कि instead of 49.5 they should be say 51 or 52, it should be bigger. Why? Because, right, when your solid is reacting, with the solution, right, what happens is कि temperature जैसे जैसे बढ़ रहा होता है, let's say आपका thermometer है, temperature आपका बढ़ रहा है, but साथ साथ आपका heat निकल रहा है, which means some of the heat is being lost to the surroundings, right? यानी कि सारा का सारा heat जो है पानी में नहीं रहता. Not all the heat that's being generated remains in the water, right? Some of it is lost to the surroundings, which means that because some of the heat is lost, the temperature increase on the thermometer is lower than it should be, right? If all the heat stayed, then the temperature increase would be greater, right? If all the heat stayed in the water, then the temperature increase would be greater. Okay. Now to avoid that, one thing you can do is cover it with a lid. Okay, you can cover it with the lid, or you can cover it with insulation. So basically, either you want insulation or you want to cover it with a lid. Okay, so you want to go with the reason is because heat loss to the surroundings. Okay, heat loss to surroundings, and the improvement is use insulation. Okay, or around the beaker. Yeah, you can say you can use a lid. Okay, cover the beaker. And I'll just double check. I believe they've said that the reaction is being carried out in a beaker. Yes, it's being carried out in a beaker. State and explain the effect of using half the concentration of aqueous copper 2 sulfate on the temperature increase for metal A. Now remember, aqueous copper 2 sulfate is the limiting reactant, right? We're using an excess of solid. We're using an excess of solid in this case, right? Which means that if you used half the concentration, assume that's the same volume. We're going to assume it's the same volume. The number of moles is equal to concentration times volume. Okay. And again, if you're using half the concentration, that
Half
means
the
that
moles.
yes, you have half the number of moles. Now, if you have half the number of moles, it means you have half the amount of reaction taking place. So because the limiting reactant is halved, the amounts that are reacting are halved, which means that the temperature rise is halved. Okay, roughly. It won't be exactly halved because of the fact that heat is being lost, but roughly, right? So we can say that the effect is that the temperature rise is approximately half. Again, it's experimental, so it won't be exactly half, but approximately half. And the reason why is because Cu2 plus your copper 2 sulfate is limiting, right? Having uh, half the concentration means the number of moles is also halved. The number of moles is halved. So again, when you use half the concentration, right, you're assuming you're using the same volume, okay? You know, the number of moles is concentration times volume. We also know that the copper 2 sulfate is limiting because that's mentioned in the question, right? In the question, they've said the way the experiment was carried out, gray solid remains, which means that the solid you're adding is in excess, right? Any solid that you're adding is going to be an excess, the initial metal that you're adding, right? So the limiting reactant is copper 2 sulfate. The limiting reactant is copper 2 sulfate. If you halve the moles of copper 2 sulfate, it means half the moles of copper 2 sulfate react, because limiting reactant, what is the limiting reactant? The limiting reactant is basically the thing that affects how much is produced, right? The limiting reactant determines how much reacts and how much product is produced. So if you have the limiting reactant, you have half the number of moles of copper 2 sulfate reacting and half the number of moles of the solid reacting. Now, if half the moles are reacting, you basically have half as much reaction. Half as much reaction means half the temperature rise. A student does a series of experiments to investigate solution R. The student leaves a wooden splint with one end dipped into R for 10 minutes. The student then places the damp end of the wooden splint into a blue Bunsen flame. So he's doing a flame test. The flame briefly shows a shade of red and then turns yellow. State two possible conclusions from this observation. We're doing a flame test. We have a red flame and a yellow flame. Now, in this, you have to be careful, okay? Because the flame due to the ion is the red flame. Okay, the flame due to the ion is the red flame. Okay, the flame due to the ion is a red flame. And then the reason it turns yellow is because you're using a wooden splint. The proper way to do this is to use a nichrome wire, right? It's just a wire that doesn't react. Because you're using wood instead of a wire for the flame test, okay? I'll, I'll remind you guys how we do a flame test. We dip a wire into a solution and then we put it into a Bunsen flame, right? We put it into a Bunsen flame, yeah? We put the drop in the Bunsen flame. Now, if you're supposed to use the wire because the wire doesn't react with the flame. But what you're doing here is instead of using a wire, you're using a wooden splint. Wooden splint is just like a toothpick, right? It's just a piece of wood. तो आप ये लकड़ी का टुकड़ा इस्तेमाल करो, लकड़ी का टुकड़ा जब जलेगा तो आपको येलो फ्लेम दिखेगी, सही. So the ion is giving the red flame, okay? The ion is giving the red flame. So now we need to figure out which ions can give us a red flame, and there's two ions that can give you a red flame, okay, which are lithium and calcium. Okay, calcium is also red or orange red, okay? It's more reddish than it is orange. So the two possible conclusions are that either lithium ions are present or copper 2 plus ions are present. Okay, so either Li plus or copper 2 plus is present. To explain why it is difficult to make a definite conclusion from the observation in A part 1. So the answer here is different ions give similar colors. Right now, because different ions give similar colors, it's hard to draw a conclusion, right? Because you don't know which ion it is. यहाँ पर the yellow part, right? You're supposed to figure out कि yellow flame wooden splint की वजह से, because आपको पता है कि आपने गलती करी है. आप लोगों को प्रोसीजर मैंने बताया है. प्रोसीजर क्या होता है फ्लेम टेस्ट का? You have to use a wire. The moment they said we were using a wooden splint, that means they're doing it incorrectly. Okay, so then that means that this must be due to the incorrect procedure, right? This must be due to the incorrect procedure. लकड़ी आग में जलती है ना, तो बस इतना आपको बस पता होना है कि लकड़ी आग में जलेगी तो उसकी वजह से ये फ्लेम होगी. The student adds dilute nitric acid to R, followed by aqueous barium nitrate. This is a test for sulfate ions. Okay, this is a test for sulfate ions. Now, in this case, as I said, this is why it's going to be beneficial to actually know the tests, okay? Because in this case, you'll have to find this piece of information right here, okay? Adding dilute nitric acid and then adding aqueous barium nitrate. Okay? It's easier if I ask you how do we test for something. अगर आपको मैंने पहले से आयन दिया हुआ है तो आसान होता है टेस्ट ढूंढना, सही है? But the other way around, if the test is given, अगर टेस्ट दिया हुआ है and finding the ion from that, okay, that's harder, okay? But dilute nitric acid followed by barium nitrate is sulfate, okay? So the student concludes that R does not contain sulfate ions. In this case, they've actually given that to you, okay, but they don't have to. State the observation which allows the student to make this conclusion. When you add barium nitrate, and sulfate ions are present, you get a white precipitate of barium sulfate, okay, which you do not see in this case. Okay, that's why he or she concludes that sulfate ions are not present. So no white PPT does not form. Okay. So white precipitate does not form, so you can say no change observed, or you can say the solution remains colorless. The student adds dilute nitric acid to R, followed by aqueous silver nitrate. This is a test for halide ions. Okay, this is a test for halide ions, chloride, bromide, and iodide, right? Silver nitrate. Again, you can go here and you can see dilute nitric acid followed by silver nitrate. Okay, it's a test for all the different halide ions. And if you're seeing a white precipitate, it means chloride ions are present in solution. So the conclusion is that R contains chloride ions. Second. Okay. The student adds aqueous silver nitrate to aqueous sodium carbonate, a white precipitate forms. The student adds dilute nitric acid a drop at a time until no further change is seen. The white precipitate dissolves to form a colorless solution. Describe one other observation. Whenever you have a carbonate reacting with an acid, you're going to see effervescence or bubbles of a colorless gas. Okay, you can also say bubbles or fizzing. Bubbles, yeah, fizzing, yeah, effervescence. So effervescence of a colorless gas, right? And write that in bracket, the gas is carbon dioxide, right? Carbonate reacts with acid to form carbon dioxide. So just why it's important to add dilute nitric acid in part C. Nitric acid is HNO3. So why add nitric acid? Because you know that nothing will form a precipitate with nitrate ions. Okay, so it guarantees that whatever the carbonate is, anything will dissolve in nitric acid and no cation will form a precipitate with nitrate. Okay, no cations will form a precipitate with nitrate. Okay, so that's why we add nitric acid. If you added something like hydrochloric acid, for example, we know that silver can form a precipitate with that, right? We know that silver can form a precipitate with that. By adding silver nitrate to aqueous sodium carbonate, okay, when you mix nitrate and carbonate, right, we know all nitrates are soluble, we know all sodium salts are soluble. So those guys aren't forming the precipitate. It's forming between silver and carbonate, and that's the white precipitate that forms. Okay, silver carbonate, that would be Ag2CO3 because silver is 1 plus and carbonate is 2 minus. Okay, so that's silver carbonate. And then if you added something like hydrochloric acid, the carbonate will react with the hydrochloric acid, but then the silver will combine with the chloride. So the white precipitate won't dissolve because silver or chloride combine, okay, white precipitate bana denge, right? So there will be no dissolving. There will be no dissolving. You want a colorless solution. So you're using nitric acid because silver नाइट्रेट के साथ कुछ भी precipitate नहीं बनेगा. Silver will not form a precipitate with nitrate, and the carbonate will react with the H plus to form carbon dioxide. Okay, so that's why we don't add hydrochloric acid. Okay, so that's why we don't add hydrochloric acid. So the reason why we add nitric acid is because Ag plus can form a precipitate, or Ag plus will form a precipitate with Cl minus, right? You don't want a precipitate to form, because if a precipitate forms, it'll be hard to see the effervescence, right? You clearly want a colorless solution in which you can see bubbling. Okay, you want a colorless solution which you can see bubbling, effervescence of the colorless gas, right? So Ag plus will form a precipitate with chloride. Okay, HNO3 is used since all nitrates are soluble. Okay, this is the full answer. All nitrates are soluble, so CO3 2 minus can be identified. The student adds a few drops of aqueous sodium hydroxide to R. State the observation the student makes which suggests that R may contain calcium ion. White precipitate. Again, there's 3 ions that form a white precipitate with sodium hydroxide: zinc, aluminum, calcium. Okay, zinc, aluminum, and calcium. White PPT with sodium hydroxide, right? White precipitate with sodium hydroxide, and calcium white precipitate with sodium hydroxide. Okay, so the observation is that you're going to see a white precipitate. And then describe what else the student needs to do to confirm that calcium ions are present. It's insoluble in excess. Zinc and aluminum are soluble in excess, right? Zinc is soluble in excess and aluminum is also soluble in excess, whereas calcium is not soluble in excess, right? Insoluble in excess. So we're going to add excess sodium hydroxide. NaOH aqueous. And the observation would be that it does not dissolve or insoluble in
सही.
excess.
सर वाइट पीपीटी रिमेन्स बोल सकते हैं.
Yes. So white PPT remains. Yeah, the white precipitate does not dissolve. Okay. The student warms the solution to form E. The student concludes that ammonia gas is produced. State the observation the student makes which confirms that ammonia gas is produced. Ammonia gas is basic, so you can use red litmus paper to test for it. It will turn blue. Okay. Again, that's given here in the test for gases. Okay. So we can say it turns damp red litmus paper blue. Identify a cation other than calcium present in R. The other cation is ammonium, which is NH4 plus. We know it's ammonium because ammonium reacts with hydroxide to form ammonia. So this is a test for ammonia ions as well, right? You can test for ammonia gas. So if you get a gas that turns damp red litmus paper blue, it means that ammonium was present. Solution R is made from a mixture of 2 different ionic compounds. Suggest the names of these 2 compounds. So in solution R, we've identified ammonium ions are present. We've identified that calcium ions are present, right? Because we got a red flame, and this confirmed that calcium ions are present, right? And we also know that chloride ions are present because we added silver nitrate, right? And we got a white precipitate. So that means that we have chloride, ammonium, and calcium. Right? These are the three ions present. So two compounds would be ammonium chloride, cation anion, and the other compound would be calcium chloride. It says suggest the names. Don't give the formula. Okay. Barium carbonate decomposes when heated. The word equation for the reaction is shown. The barium carbonate decomposes to form barium oxide and carbon dioxide. This is similar to calcium carbonate forming calcium oxide and carbon dioxide. Plan an experiment to determine the percentage loss in mass. Okay, so always highlight or underline the objective. Okay, you want to determine the percentage loss in mass when barium carbonate is heated. Why is mass being lost? Because carbon dioxide is being lost. When you heat barium carbonate, carbon dioxide बनता है और carbon dioxide गैस निकल जाती है, barium oxide पीछे रह जाता है, तो mass कम हो जाता है. Alright, so your mass decreases as CO2 is lost. Your plan must include the use of common laboratory apparatus and a sample of barium carbonate. No other chemicals should be used. Your plan must include the apparatus needed, the method to use, and the measurements to take, procedures to ensure that the percentage determined is as accurate as possible, and how the measurements are used to determine the percentage loss in mass. You may draw a diagram to help answer the question. Okay, so I'm actually going to show you guys the diagram, simple diagram. Okay, okay. You have your solid barium carbonate here, okay, and you're going to heat it. Okay, you just have it in a container. This is called a crucible. It's just a ceramic bowl, okay, that we use for heating things. सही है, एक पत्थर जैसा प्याला होता है जिसमें आप हीट करते हो strongly solid को. The lid should not be sealed. Okay, now why was that heat here? This is barium carbonate, BaCO3, right? Barium 2. Okay, so again, now I'll explain what we're doing here. Again, you don't have to draw the diagram. Okay, so even if you don't draw the diagram, it's fine. Okay, but basically when you heat the solid, right, the reason you want a lid is because if you guys have ever if you guys have ever seen popcorn machines, right? जब आप popcorn बनाते हो उस container में, right? When you're making popcorn, right? You can see that the popcorn basically flies out because of the heat, right? Popcorn flies out because of the heat, right? That's called spitting. Spitting is basically when the solid particles fly out because of the high temperature. Okay. Even when you look at a pan and a frying pan, right? If it's very hot, right? Oil के droplets बाहर निकलते हैं, right? उड़ते हैं, right? छींटे उड़ते हैं, right? वो क्यों उड़ते हैं? Because of the high temperature. Okay, that's called spitting. Spitting is basically when the solid particles or liquid particles uh, basically like spit out of the container, right? Now the reason we cover it with the lid is so that we don't lose the barium oxide. Okay, वरना क्या होगा, आपका solid जो है उसके particles उड़ेंगे हवा में, right? You don't want to lose that, right? You need to know how much barium oxide was left, right? Because आप initial mass लोगे barium carbonate का, right? You're going to take the initial mass of barium carbonate and you're going to take the final mass of barium oxide, right? And you can find the difference, and that will tell you how much mass was lost, right? That will tell you how much mass was lost. So you don't want to lose any of the solid, okay? But you don't want to seal the lid because you want to allow carbon dioxide to escape, okay? You want to allow carbon dioxide to escape. All right, so that's basically the setup. Okay, so the way to do this is basically you can transfer. Okay, so so what you're going to do here is पहले तो आपको क्या करना है, आपने एक certain mass डालना है barium carbonate. Okay, that's the first thing you have to do. You have to add a specific mass of barium carbonate. Okay, so we're going to add. Okay, we're going to add a sample of solid barium carbonate. We're going to add mass of solid barium carbonate to a crucible. Okay, okay, and then what we're going to do is we're going to weigh the we're going to weigh the crucible and the barium carbonate. So we're going to weigh the crucible and the barium carbonate. So in this experiment, they will allow you, okay, in this experiment, they will allow you to use a beaker. Okay, they will allow you to use a beaker as well, but a crucible is the better choice of apparatus here. Okay, so you're going to weigh the crucible and the barium carbonate, okay, and then you're going to cover the crucible, okay, with a lid. Again, this could also be a beaker, okay. Even if you don't use a lid, okay, they accept that. They don't really necessarily allow, they don't necessarily require you to use a lid either. I'm just telling you the proper way to do it, okay. You don't have to use a lid also. They like, you won't lose marks for it. So you cover the crucible with a lid, okay, and heat, okay, using a Bunsen burner, okay. Okay, and then reweigh and then weigh, reweigh, okay. You should allow it to cool first. So then allow it to cool and reweigh the crucible and the solid. Okay. Now, how do we know that the reaction has gone to completion? So let's say I have 205 grams of barium carbonate plus crucible, right? Let's say 5 grams of barium carbonate and 200 grams ka container hai, okay? So let's say I have 205 grams in total, right? That's my initial mass, okay? Let's say I heat it and I get a mass of 202 grams, okay? Let's say I heat again and I get a mass of 201.5 grams, right? That means that some of the carbonate was still left, right? Some of the carbonate was still left, which meant that once I heated it, it broke down further, right? Some carbon dioxide was lost. Let's say I heat it again. I get a mass of 201.5 grams again. That meant that heating it had no effect on the mass. Heating it had no effect on the mass, which means that the reaction must have gone to completion, right? No more carbon dioxide is being produced. So you have to heat and reweigh until you see a constant mass. Okay. आपने जब कांस्टेंट मास देख लिया तो आपको पता है कि अब मजीद कार्बन डाइऑक्साइड नहीं बन रहा हीट करने से, इसका मतलब रिएक्शन मुकम्मल हो गया. Okay. So what we're going to say here is that you're going to reheat and reweigh until the mass remains constant. Okay, until the mass remains constant. So you reheat and reweigh until the mass remains constant. Okay, that basically tells you that the reaction is complete. Okay, and then what are you going to do to find the percentage loss? Right, you're going to take the initial mass minus the final mass over the initial mass, right? Because you want to find the percentage loss in mass, so you're comparing it to the initial mass. So this is how much mass was lost, right? Initial minus final. So let's say after 205 minus 201.5, just as an example, right? That means 3.5 grams was the loss in mass divided by the total mass at the start, divided by initial mass times it 100. Okay. All right. One last thing I want to mention is that, and then once you're done with this, once you're done calculating the percentage loss, okay, you should repeat the experiment. Okay, repeat the experiment and find the mean percentage. So for example, if you got, say, something like 4.8% the first time and 5.0% the second time, and then the percentage is 4.9%, right? You take the average of the two percentages that you get. And this is important because it improves the reliability of the experiment, because if you do multiple multiple trials, for example, and let's say you get two very different values, then you know that one of them was wrong, right? So, for example, if you got 3% and 6%, you know that you should do it again until you get two values that are very close to each other, and then you can take the average of those two values. Okay. So you should always repeat the experiment to improve the reliability of the results. And one thing I forgot to mention here is that whenever you're weighing something, okay, you should use a mass balance. Always measure the instrument. Always mention the instruments that we're using. So instruments or apparatus that we're going to use using a mass balance. We only have to mention it once. Only mention it once, right? So yes, you don't have to mention it again. You don't have to mention it when you're talking about reweighing it because you've already mentioned the instrument. Okay, but you should mention the instrument once. Because the question clearly said that all the apparatus and instruments should be mentioned. Okay, so that's how we do this.